In today's lesson, we're going to be talking about energy flow throughout a food chain, as well as percentages. So here we see a food chain, or I guess a food circle if you prefer to think about it that way. We have producers who make their own energy off of energy that they obtain from the sun. And that energy then, and that producer is then consumed by a consumer, a primary consumer, which are usually herbivores. And they obtain about 10% of the energy that the plant gets. Secondary consumers eat primary consumers, so they're carnivores, and they get about 10% of what the primary consumer has, which is even less, and we'll go over kind of what that means later on. And then we have tertiary consumers, which, as you can imagine, eat secondary consumers. So we are also considered tertiary consumers. We don't eat foxes, like in this picture, but we do eat salmon, which eats smaller fish. And so that's eating an animal that eats another animal. And so as you can imagine, that's even less energy because we're only getting 10% of the energy from the secondary consumer, which got 10% from the primary consumer, which got 10% from the producers, which is quite small if you think about it. And then eventually all of these organisms die, and that's where decomposers come in, and they attain energy from what's left over of the dead organisms. And they put a lot of nutrients into the soil, which aid into the growth of plants, which is why it's more of a circle than a chain. So now we'll talk about where is that energy? Why are we only getting 10% of what we're consuming? So here, when grass is absorbing energy from the sun, a lot of that light and energy is being reflected off of the plant. And so it only gets a certain amount of energy that actually goes into the grass, into the plant, and that plant uses most of the energy that it does get into it for respiration. So then herbivores or primary consumers come and they eat the grass or the plant, and they only get 10% of what's left because a lot of it has already been used for respiration and survival. And so consumers come and they eat that, and then they only obtain 10% because of what's left, like I just said. And then the energy that they do have goes mostly towards respiration. It goes towards movement. It goes towards reproduction. It goes towards survival in general. And then what doesn't get used is wasted, as you can see. And then when we get to secondary consumers, they get even less energy because a lot of that energy has already been used and it's been wasted. And so that's why they only get 10% of what primary consumers eat, or what they are, really. And then tertiary consumers get even less, which is why oftentimes tertiary consumers are omnivores. They don't just eat secondary or even primary consumers. They also eat producers because they need to get that energy from other sources because they can't just rely on the itty-bitty amount of energy that's left over when they eat secondary consumers. So here's a little pie chart on energy flow. So as you can see, 90% of energy is not used when you consume food. 7% is digested or excreted, and 3% is actually absorbed into the body to be used for movement, for survival. So it's pretty amazing what our bodies can do on just 3% of the energy that we consume. And here's just a nice summary of in this triangle, in this energy pyramid, to show kind of how energy works. So as you can see in the bottom, we have the decomposers and the primary producers, and they have the most amount of energy from what they're consuming or producing. Primary consumers get less energy, they get 10% of that. Secondary consumers then get 10% of what primary consumers, and tertiary consumers get 10% of what secondary consumer energy. And so, just like this pyramid gets smaller, so does the amount of energy that the consumer obtains get smaller. And so now we're going to talk a little bit more about percentages and how to figure out these percentages, and so that we can know what it really means and what's going on and how much energy we're really getting.